All right, guys, welcome to this page of the notes. Let's keep working on this idea of simplifying complex rational expressions, and we'll jump in by taking a look at this example problem that I've got for you here. Again, we recognize that it is a complex rational expression because I have a rational expression, but the numerator is a rational expression. The denominator is also a rational expression. Again, in kind of the sort of simplified form. It's keep it, change it, flip it from middle school, but we know that all you need to do is multiply by the reciprocal of your denominator. So I'm going to wind up here with here we go, x plus 3 squared all over x squared minus 16 times, flip the bottom, x plus 4 over x plus 3. And then again, I take a quick look at this. They should be just jumping out at you at this point. I've lost track of how many of these we've done. X squared minus 16 is a difference of squares. X plus 3 squared, x plus 4, x minus 4 times x plus 4, x plus 3. All right, the x plus 3 in the bottom cancels with one of the x plus 3's in the top, leaving with just an x plus 3. That reduces to a 1. The x plus 4 cancels with the x plus 4 on the bottom. Those both reduce to 1's, leaving me with x plus 3 over x minus 4 multiplied by, guys, look, those cancel. It's just 1 over 1, which is just 1. So I'm left with x plus 3 over x minus 4. So my final answer, simplified form, the quantity x plus 3 over the quantity x minus 4, where x cannot be 4. One more for you guys. Let's go ahead and take a look at this one right here. Again, it's a complex rational expression. So we're going to multiply by the reciprocal. Y minus 7 over y minus 3. Multiply by the reciprocal. Well, flip the bottom, y squared minus 4y minus 21, all over y squared minus 49. Okay, at this point we should be getting pretty comfortable with factoring. This is a general trinomial. I know that because it's a y squared and 21 is not a perfect square. So hopefully it'll factor pretty easily. I don't know, we'll see. Y squared minus 49 is another difference of squares. It is going to show up over, you'll be sick and tired of difference of squares by the time we get to the end of this chapter. So let's factor. We wind up with y minus 7 over y minus 3. All right, so the top, easy bit, y and y. I need a 21 and a 4. Well, that's going to be a minus 7 and a plus 3, right? Yes, it will be. And then in the bottom, I'm going to wind up with a y minus 7 and a y plus 7. All right, so let's see what happens here. I wind up with, actually, not that much cancels. This is it. Y minus 7 and y minus 7. That leaves me with 1 over y minus 3 multiplied by, nothing up there canceled, so it's just going to be a y minus 7 times a y plus 3. In the bottom, y plus 7. Go ahead, multiply the numerators, multiply the denominators. So y minus 7, y plus 3, all over y plus 7 and y minus 3. Now this, I love this example problem because here's what happens. Again, we've seen this before, right? Where I'm really close, right? Y minus 7, y plus 7. The only difference is the sign. But in this case, pulling out a -1 wouldn't help, and here's why. The y's have the correct sign. If I pull a negative out of this guy, yes, that 7 will become positive, but the y will become negative. I'll have a minus y and a plus y. They still won't cancel. So while in many cases pulling out a -1 will help, it won't always do the trick for you. And this is one of those cases where pulling out a -1 actually doesn't help us any. The y plus 3 and the y minus 3 as well. Pulling out a -1 isn't going to get you something that cancels. So this actually is simplified. There's nothing else I can do to it. Go ahead, restrict that domain. Y cannot be, let's see, a -7, and y cannot be a +3. All right, guys, that takes care of this set of notes. Hopefully at this point you feel real comfortable simplifying rational expressions, and then even going beyond that, multiplying rational expressions, dividing rational expressions, and all of the factoring of polynomials that goes with it. I had so much fun taking a look at simplifying rational expressions with you guys. I can't wait to see you next time. Bye.